We are jumping to lesson 7 just because of the day and because who's here. Okay, so this is functions. Still same part of the unit. Unit 3, lesson 7. Everything's the same. And the reason it also kind of helps us because we've already talked about these things. So we're reviewing the 6 ways relationships can be reviewed. We talked about it yesterday. Words, table values, ordered pairs, mapping diagram, equation, and a graph. Yesterday we talked about domain and range. A couple of little mistakes. Make sure that you're every time. Okay, I'll say this. This is an every time thing. Every time you have an x-intercept, the point of the x-intercept should be something 0. Something 0 every time. Because in order to cross the y-axis or the x-axis, y has to be 0. Your y-intercept every time should be 0 something. So a lot of you got the work right and found your x and y's. Some of you guys forgot to write them as coordinates. Okay, some of you guys wrote them as joined coordinates. Okay, don't do that. Okay. Next thing, domain range review. Well, yours was like this. It was at 3. I told you 3 was the highest point. Whenever you have a parabola growing infinitely laterally, you need to understand what that means when I say that. It's growing forever this way, forever this way. Arrows means it's continuous. This means there's nothing for x that's a problem. So your x for your domain is all real numbers. Your y is 3 and everything below it. So you'd say y less than or equal to 3 for your range. That's from your exit card yesterday. Okay? Out of those 4 things, okay, those are the 4 main concepts. So if you missed 2, you only got half things yesterday. Got to fix it. Got to ask. Okay? All right, here we go. Functions. To illustrate the concept of function, we'll look at 2 relations described in words of domain 1, 4, 9, 16 and a range 1, 2, 3, and 4. So on 1 is a multiple of, and 2 is a square of. Okay? So what we're doing is 1 to 1, 4, 2, etc. Complete the arrow diagram is a multiple of. So if it's a multiple of, like what's a multiple of 9? Anything else? 1. How about 16?
4.
Good. Just draw your arrows. Okay. Square of. 1 squared is 1. So 4 to 2, 9 to 3, 16 to 4. Straight across. Okay. So we're going to complete the set of ordered pairs up here. So 1, 1, 4, 1. And let's see here, what else are they doing? Are we doing ordered pairs? Oh, sorry, we're doing ordered pairs here. I got you now. Okay, 1 to 1, 4 to 1, 4 to 2, 9 to 1, 9 to 3, 16 to 1, 16 to 2, and 16 to 4. Okay, write the ordered pairs for the second one. It should only be 4. Okay, for the second one, you should just have 1, 1, 4, 2, 9, 3, 16, 4. We're just doing all the stuff here. Okay, and we're going to plot the ordered pairs. Sometimes visually is the easiest way to see this, but if we plot the ordered pairs, so we're plotting all these points here, so it might take a little bit. So we have 1, 1. Let's just do the dots this way. So 1, 1. We have 4, 1. We have 4, 2. We have 4, 4. We have 9, 1, 9, 3. You should have a 4, 4. I think we forgot 4, 4. 9, 3, 16, 1. So yeah, if you want, we should have a 4, 4 up here. We forgot to draw the arrow. Okay. 16, 1, 16, 2, 16, 4. Well, if we look at the other one, we have a 1, 1, 4, 2, 9, 3. So which one looks somewhat linear? The second one. Which one doesn't look linear at all? First one. Okay, that's going to be your indicator of a function or not. I'm just going to kind of break the news to you. This is not a function. This is a function. Okay, so the example of factors is not a relationship that we can demonstrate as a function. So look, it's all over this, but it's scattered. Okay, so if we keep going here, a function is a relation of a function is a special type of relation in which each element of the domain is exactly related to one element of range. So that means is your x, the reason the one at the top is bad, you can look at your mapping diagram. This is a no-no for a function. 4 can't go to multiple locations. That makes it not a function. So this is it. Ready? Here's the definition of a function that you need to know. Every x can only have one y. Every x can only go to one y. Okay? But don't be confused. It's okay if 9 and 4 go to 2. That's okay. They can go the same y, but they can't go to different y's for one x. Does everybody hear me? Every x can only have one y. No? Not getting it? That's perfect. Thank you for telling me that. Okay, so what I'm saying is, so this right here is not a function because 4 is going to 2 things. Okay, that makes it not a function. But, like here, if I just, let's just pretend, if I said 9 goes to 2, and 16 goes to 2, that is a function. That's okay. When it's not okay is if 4 then went to 4 as well. Then this is going to 2 things. As soon as the x is going to 2 things, it's not a function. Okay, so you look at the left side. We're going to have some tests. We're going to talk about some other things. But, so sorry, one more thing here, Noah. Maybe let me know if this helps at all. So 1, 2, and 3, 9, 10, 11. Okay, if they all went to 9, is that a function? Yes. Yes, that's a function. 3, 4, and 5, 7, 9, and 11. Boom, no. I split 3 to 2 spots. No, not a function. Okay, that's when we have the issues, okay? All right, if we need more on that, hopefully the rest will kind of touch it up. If not, ask me after. Okay, so here it is from their words. A function relation or a function is a special type of relation in which each element of the domain is related to exactly one element of the range. That means x has one y. Okay, if any element of the domain is related to more than one element of the range, it's not a function. So, in the exploration, so stuff we did up there, we compared all the things we were looking at. Explain how we can determine relations to function by looking at the following. An arrow diagram. This one is if your independent or x splits to 2 numbers, no good. Okay, so we just talked about that. We just used that. How about the ordered pairs? How can you tell the ordered pairs? Yeah, 2 same x's that go to different y's. Example, very short one. 2, 4, 3, 2, 2, 5. That makes it not a function. The 2 is going to 4, the 2 is going to 5. Okay, because the 2 is my x, right? The 2 is my domain. In the graphs, yeah, 2 dots above each other, right? If you look at that scatter plot that you guys made, there's a lot of dots right on top of each other. That means no good. So making sure points directly above each other. Oops, that's one word. Okay, so like example. So like these would be, those would be a problem. So they're right on top of each other. Yep.
What if it's just like one straight line that went straight up and down?
It's not a function.
Isn't it linear though?
Correct. It is linear, but it's not a function. It's a function of x. We'll get to that later. But good question. Yeah. Correct. You can have a flat line. Flat line's good. Yep. Okay, good. Each of the following graphs a relation. Okay, so classify the following statements as true or false. So A, for each input value, there's only one output. So that means it's a function, right? So this would be, is there any spot that the dots are on top of each other here? No, there's not, because this is a parabola. You should know that's a function, right? Okay, so this would be, we're putting true or false, so this would be true for A. How about B? True, good. Okay, so again, what am I looking for? I'm looking for stacked points. Well, also, I'm just going to teach you because they're coming down to it. The vertical line test. You can put your hand. If your hand ever hits the graph twice, it's not a function. How's that one? Am I hitting it twice somewhere? No. Once, right? True. C. I'm hitting it twice. Same thing here. I'm hitting it twice. False. Sound effects help. What's wrong, Josie? No. Like, where would it hit it twice? Like, where? Every time I go through, I'm going to hit it once. So here, watch. This might help. We'll use our handy-dandy tools here. So here you go, Jose. Ready? Yeah, we can't go that. We have to be straight up and down. Okay. Got it? But look, we can use this as our cheating. Oops, come on, move, work. Only got through once, right? Once. Okay. Vertical line testing. Use your pencil. Okay. For each output, there's only one input. So how does that change my vertical line test? Instead of vertical, it's going to be horizontal, right? So we're looking this way. So this one is, for each output, there's only one input. That's false here. How about here? That'd be true. We're okay there. False. Good. True. This is a sideways parabola. Easy, easy. Okay. The relation is a function. So which one means it's a function? The top row or the second row? This row determines if it's a function or not. So it's true, true, false, false. Any questions so far? Okay, we're almost there. So now it's going to talk about the vertical line test. We already talked about this. Let's see what's being, what's this say here? From graph C, write two ordered pairs which show the relation is not a function. Draw a line joining these points. So if we go back to graph C here. Okay, so all they're saying is this point and this point makes it not a function because they're on top of each other. So those points, I'll write it here, guys, but you're on part B on the next page. So for B, that point for me is -1, 3, and -1, -3. Those points prove that C is not a function. From graph D, write 2 points that makes it not a function. So I'll do this one here, that, and that. Draw a line to them. 4, 2. So this is for part D, or C. 4, 2, and 4, -2. Make that graph not a function. And we already did this. On graph A and B, draw a series of vertical lines. Do they cross ever twice? No. Okay, so that's no there. So vertical line test. This can be used on a graph relation. You take any vertical line, your pencil, your hand, however you want, you go across the graph, and if you ever intersect twice, it is not a function. Or more than twice. Excuse me, more than once. Twice or more. Okay, let's go through these. Let's see if we learn this stuff here. All right, we'll just start with, we'll start this way. Maddie, is A function by the order points? And where is the part that stands out? You're correct. Why not? Oh, sorry, I'm talking about A. And they... Good. 6 goes to 7, 6 goes to 8. Not a function. 6 would have to go to the same thing twice. Okay, so this is good. 6 went to 7, 6 went to 8. Not function. Okay, Logan, how about B? Yep, 3, easy way to check, 3, 2, 4, -3 are all different x's, so we're good. There's nothing that's going to make us believe otherwise. Okay, Josie, C. It is, right? Correct. It is a function. Okay, remember, they're not split. It's not split anywhere on the left side. They can go to the same thing. It's not split, so it's okay. All right, good. And then what do you think, Lauren, for D? No? Why not? And correct, and these points are stacked. Okay, good. Move away. Okay, anything else? All right, let's look at this. Relation connecting the provinces and territories of Canada with their capital cities. Oh, it's in words. So the relation connecting the provinces and territories of Canada with their capital cities. So you're connecting through the whole provinces unless they're stacked. I don't know what the capitals are in Canada. That's not my cup of tea. So I'm going to assume that that is a function, that none of them are directly atop each other. So we'll say yes. Is there a capital directly on longitude, latitude the same?
I think so.
Okay. So if there is, then you can put no. But if you understand the concept, we're good.
But it's also a territory, so it's a little bit.
Yeah, that's okay if it does that. Yeah, it's okay if it goes like. It goes back? Yeah, that's okay. It can go any direction it wants. Like, it can do that. That's fine. No, this wouldn't be. Okay, so then if that's the case, then it'd probably be a no. Okay. The next one's a no. That's a yes. Yeah, that's a yes. Nothing. It never hits twice. This one would be a no. Oh, okay. Gotcha. Gotcha, yeah. Okay. Function as mapping. Okay, a function from set D is a domain in the set R range, in relation in which the D element is exactly one element of R. It's the same we've already said. Complete the following for the function of the square of the first page of the lesson. So we already did this. This was 1 was 1, 2 was 4, or 4 was 2. And then it was 16 was 4. Okay, so it says consider the following 3x plus 1 with a domain of -1, 0, 1, and 2. So complete its mapping. So -1, what would the value of -1 be? Now, don't panic. All you have to do is put -1 in for x. 3 times -1 is -3, plus 1 is -2. Put 0 in. That's 1, because 0 plus 1 is 1. Put 1 in. 3 times 1 plus 1 is 4. Put 2 in, 7. List the elements of the range of this function. The range would be the list of numbers we just did. -2, 1, 4, 7. Okay, show it as an arrow diagram. Okay. -1, 0, 1, and 2. -2, 1, 4, and 7. There's my arrow diagram. Set of ordered pairs. Yeah. And then plot the points. So there's 1 point, 0, 1, there's another point, 1, 4, 0.27. Another point. And that looks what? Linear, right? Good. All right, I think that's how we end. Okay, so just in review here, just let's look a couple of these. You know, which of these are functions? Is that a function? I think that's good. I think it's pretty close.
The one line looks like it's straight.
Yeah.
Right there.
It's okay if it's straight though.
No, like
Oh, right here?
Yeah.
Yeah, I think that's slanted a bit. Maybe we'll have to check. We'll see what the key says, but I'd probably say yes. About this one?
Yeah.
Yes. Okay, good. All right.